Morning guys, my name is Evan and I'm here to explain you about my reattachment of the past. The big question in this term is why do visionary leaders adapt? And the focus question, how can human analyze transformation based on physics concept and law in a day-to-day life activity? Now we're moving on in outcome. In outcome, we're able to develop a forward-thinking design based on the understanding of Newton's law of motion. The second one is able to analyze a daily life problem based on the principle of work, energy, and power. Here are the vocabulary that used in this video. From this photo, we could analyze the ball. It's me kicking the ball. And in this photo, we could also find an important point like the free body diagram and a Newton law. For the free body diagram, we could find the weight or the gravitational force. The gravitational force is going towards down. Gravitational force. Not only that, we could also find the normal force. Normal force with 90 degrees go up, and the opposite of the gravitational force. We call it the normal force. Not only that, we could find friction. Friction is the resistance of the motion in one moving object, which, when I kick the ball through the right, the friction will move on to the left. This is the friction. In this photo, we could also analyze the Newton law. As we can see, we could analyze the first law, which is the inertia. In the picture, the ball stays in the ground and it stays at rest. This is why we call inertia. It stays at rest and doesn't make any acceleration or move. Next, we also can analyze the second law, which is the acceleration. It's acted by an unbalanced force. From this picture, we could see that my feet, when kicking the ball has a mass and the velocity is in my feet. When I kick the ball through the top, it could make an acceleration. And we could also analyze the third law, which is action and reaction. From the picture, we could see that the ball bounced back and hitting the field. It's hitting the field. And as the action is when a ball strikes to the ground with a certain force, and this is the action. As for the reaction, is when the ground pushes back the ball with an equal force, and the ground pushed back, so it's going up, and this is why we call it the reaction. And in this picture, we could not see the law of conservation because the ball just stays in the ground and not moving. Now moving on to the next photo, is me holding two objects, which is the paper and a trophy. This picture is different from the first picture because the object is just standing still. And from this photo, we could analyze the first, free body diagram. The free body diagram, we could analyze the gravitational force, or we can say as the weight of the object. It's going down. This is the weight. Weight 1 and weight 2. 1 and 2. And from the Newton law, we can only analyze the first law, which is the inertia. Because the object is just standing still and not making any movement. Now we're moving on to the next photo, which is a slingshot. In the slingshot, we could analyze many things, such as the Newton law, the free body diagram, and also the law of conservation. In the free body diagram, we could analyze the weight of this ball, which is going to the down. This is the weight or the gravitational force. Next, we could analyze the tension. Because there are a rope in here, now we can see the tension. Tension is going up. Because tension is interact with the rope, the string, and many kind of other like that. This is the tension. And we could also see there are the normal force which is going up. And lastly, we also could find the friction. The friction is going to, because of the object is going to the right, the friction will always go to the left. This is the friction. In this picture, we could analyze the Newton law number 2, which is the acceleration. The more force applied before the swing, like going here, then the acceleration of the swing will be higher. So as we know, the greater the force is the greater the acceleration. The last thing is the law of conservation mechanic energy. As the data given, the mass of this ball is 140. The gravity is always 10 meters per second. The velocity of the speed is 20 kilometers per hour. And the height of this object is 40. Now we count the potential energy, which the formula is mass times gravity times height. As we know, 140 times 10 and times 40 is equals to 56,000 joule for the potential energy. Next is the kinetic energy. As you can see, the formula is half bracket mass times velocity to the power of 2. And the mass that we found is 140 kilogram. The velocity is 20 kilometers per hour. And as total, the kinetic energy is 28,000 joule. Lastly is the ME, or the mechanic energy. So the formula is the potential energy plus the kinetic energy. And as total, the mechanic energy is 84,000 joule. Thank you for listening to my presentation. I hope it inspired you.